Before that, we should know about small terms and then characteristics, how the images are formed in a spherical mirrors. So, let me know about the paraxial and then marginal axial. And before that, what is principal axis? Sir, this is the concave mirror, sir. All the incident rays are reflected by the inner surface. So, this should be called as concave mirror. The center part of the spherical mirror is center of curvature, and then midpoint of the concave mirror is pole. The line joining the center of curvature and then pole is called principal axis. Principal axis. Now, I am going to draw the very closest distance parallel to the principal axis. So, here, now I am going to draw the parallel line to the principal axis. This should be called as paraxial line. Paraxial line. The paraxial line means the closest line drawn to the parallel of principal axis is called paraxial line. If suppose the faraway line is drawn parallel to the principal axis, the faraway line drawn for the parallel to the principal axis is called marginal axis. This term should be known for the purpose of how the images are formed in a spherical mirror. Okay, students? So, the parallel to the closest line, that should be called as paraxial line, and then faraway line to the parallel to the principal axis called marginal axis. And the next one, image formation in spherical mirrors. Image formation in spherical mirrors. How the images are formed in spherical mirrors, let me discuss one by one. For example, I am going to take the concave mirror. We know very well all the reflected rays are come from the inner surface of the spherical mirror. So we know very well the center part of the spherical mirror is center of curvature C, and the midpoint of the concave mirror is pole. The line joining the center of curvature and then pole, that should be called as principal axis. If suppose the incident ray is parallel to the principal axis, when your incident ray is passing parallel to the principal axis, it will be hit on the inner surface of the spherical mirror, that is a concave mirror. It will be reflected and passed away through the principal focus F. Very important word. You are just allowing the incident ray parallel to the principal axis, and it will be emerged out. That means it is reflected through the point of principal focus, that is focus point. This is the first case. And then second case is, again I am going to take the concave mirror. All the light rays comes from the inner surface. Center of curvature and then poles. It is connected to the principal axis. Now, I am going to pass the incident ray. I am going to pass the incident ray through the principal focus F. So, the line is passing through the principal axis. What will happen? The incident rays fall on the concave surface and it will be emerged out and reflected parallel to the principal axis. So, all the ray of incident ray is passes through the principal focus, the output or the reflector light ray is parallel to the principal axis. It is the inverse of first case. Am I right? In the first case, you just allow the parallel line to the principal axis, it will be emerged out and it will be reflected at the point of focal point. Now, in the second case, you just allowing the input, that is the incident ray, towards the principal focus and it will be reflected to the parallel to the principal axis. And then third case, let me take one more concave mirror. The principal axis connecting the center of curvature and then pole. So in this point, center of curvature. Now I am going to pass the incident ray through the center of curvature. Through the center of curvature, like this. Through the incident ray from the point of beyond the point C, but the rays are passing through the center of curvature. It will be impinged on the reflecting surface of the inner layer of the spherical mirror. It will be reflected in the same path. In the third case, if you are supposed to allow the incident ray through the center of curvature, the reflected ray is always in the same line. So entering and then relieving in the same path. This is the main features in the third case. And then fourth one, if you are supposed to allow the light, directly to the pole point, directly towards the pole point, the incident rays is impinged to the pole point. At the same time, the reflected ray is also reflected. It's the equivalent of incident ray. So now in this case, the principal axis is acts on a normal line. So from the point of incident ray, it will be impinged to the point of P and it will be reflected in the second, that is the bottom of the principal axis. These are all the factors, the image formation in the spherical mirrors.